we'll be working with the net change as an integral of rate. So we'll just jump into this one using these guided notes. So let's look at problem number 1. One of the integrals below is the total distance traveled and the other is the total displacement over the interval t sub 1 to t sub 2. Which one is which and what is the difference between the two? Well, if you just think about this, an integral calculates the area between the function and the x-axis. So if I were to have some function drawn, something like this, sure, something like that, and I were to calculate this from a to b, so if I calculate that integral, the area above the axis is going to be positive and the area below is going to be negative. So in this picture, it could be a wash. If I were to calculate this, it could be something close to 0 because it looks like about as much as below as is above. So if you're just calculating an integral, it's just going to give you the net result of the plus and positive and negative areas. If I take the absolute value of this, it would take the part below the axis, it would take this part and it would flip it above. So the absolute value of this would simply be above the axis. So when you're talking about distance, you're talking about the accumulation of distance traveled. So for instance, if I go from my house to Timberline and from Timberline to home, my displacement would be 0, but the distance traveled would be however many miles it is there and back. So to make something simple complicated, this is displacement, and this is distance traveled. So distance traveled it won't be negative. Let's do an example with this. Plane travels 560 kilometers from Los Angeles to San Francisco in 1 hour. If the plane's velocity at time t is v of t in kilometers per hour, what is the value of the integral from 0 to 1 of v of t dt? So what we're going to do is set up an integral for this. So we're going to evaluate the integral from 0 to 1 of what it gave us for the velocity. So we integrate, plug values in. So this would be 560t evaluated from 0 to 1. So this would be 560 minus 0, or 560 kilometers. So what that represents, the antiderivative of velocity would be the position. So this is the position function once we integrate it. Okay, so let's look at this question. This is more of a general question. So guided notes, when we do these in person, they make a little more sense because we're asking a lot of questions of each other and all that. So it seems a little weird to do them without an audience. Which of the following quantities would be best represented as derivatives and which as integrals? Explain your reasoning. Velocity of a train. Well, velocity is the first derivative of position. So this would be something that I think would make more sense as a derivative. Rainfall during a 6-month period. So that's going to be the accumulation of rain over a 6-month period. So it's not going to be day 1 and then it goes away and then rains day 2 and we have another set of rain drops. This will just be an accumulation. So anytime we talk about an accumulation of something, whether it's people, rain, whatever, this is best described with an integral. mileage per gallon of an automobile. Well, what is that? That's a rate. So a rate is usually when we take a derivative, we get a rate. Increase in U.S. population from 1990 to 2010. So this is another accumulation. How many people, how big was the increase in number of people? So this would be an integral. Okay, so those are just some things to think about as you're working through problems like these. Let's do another one. So water flows into an empty reservoir at a rate of 3,000 plus 20 t liters per hour. What is the quantity of water in the reservoir after 5 hours? So this one's kind of giving you some information. So it says it's a rate of 3,000 plus 20 t. And what is the quantity of water in the reservoir after 5 hours? Well, that's talking about an integral. So what it's saying is, here's a rate, take the integral. So we'd have the integral from 0 to 5 of 3,000 plus 20t dt. And we calculate that. This would be 3,000t plus 10t squared evaluated from 0 to 5, which would give us 15,000 minus 0. Oh, I'm sorry. It's going to be 15,000 plus, then I have to evaluate 5 in t squared, so this would be 250 minus 0. And so we'd get 15,250 liters. Okay, so these integrals are relatively simple. It's just a matter of setting them up is the challenge. Okay, so let's look at this one. So we're given this chart of information, and it says the rate in liters per minute at which water drains from a tank is recorded at half-minute intervals and is displayed in the table above. Compute the left endpoint approximation to estimate the total amount of water drained during the first 3 minutes. So, we're estimating an integral value using some values which aren't consistent. So let's see what we can do here. So left endpoint, let's look at the, see if this is consistent here. That is consistent. So it's 0.5, goes to 0.5. So these are all increasing by 0.5, that's good. And so we can have a left endpoint, our width is going to be 0.5 of those rectangles, and we're just going to evaluate this one, this one, this one, this one, this one, and this one, because that's the left endpoint. So we'd have 50 plus 48 plus 46 plus 44 plus 42 plus 40 times 1/2. So this comes out to 100 and it's 203.08. So this would be 154. And this is liters. And you have to be careful with the units. So if it's liters per minute and we're integrating, we will just have liters left. Now, next problem or next question is an extension of that one. So 5b says, is your estimate of displacement an overestimate or an underestimate? And we don't have a function exactly, but I do know this from those points. So here's a bad sketch of what's going on with that. So at 0, I have 50, then 48, then 46, 44, 42, 40, and 38. So the function is decreasing like that. And we are using left endpoint rectangles. So if I have left endpoint rectangles, I would have, let's do that in a different color. I would have rectangles like this. So they would be over the line. So this would be an overestimate. Okay, so these types of problems are just getting you to set up integrals and starting to understand the difference between the rate and accumulation and their relationship. So that is net change as integral of rate.